Welcome to the GOTO podcast. Each episode covers the brightest and boldest ideas from the world's leading experts in software development. Tune in for practical lessons, compelling theories, and plenty of inspiration. GOTO gathers the brightest minds in the software community to help developers tackle projects today, plan for tomorrow, and create a better future. Stay up to date with the latest in tech through GOTO's top-rated events held online and in person in cities like Amsterdam, London, Copenhagen, and Chicago, and by subscribing to the GOTO Conference's YouTube channel, where you can find thousands more high-quality dev talks. Learn more at gotopia.tech.
Hello, and good morning, good afternoon, good evening, wherever you are, whenever you are. Welcome to another GOTO Unscripted conversation. My name is Kevlin Henney, and I'm here with Audun Strand. If you'd like to say something, introduce yourself.
Yeah, sure. As Kevlin said, my name is Audun. My title is of principal engineer, but I work at NAV, which is basically a big governmental agency in Norway. I think in almost every other country, NAV does what 15 or 16 different organizations does. So we're big and we support, we say that we support Norwegians from before they're born till after they're dead. So that's kind of the scope.
So that is a full life cycle. Yeah, that's full life cycle support.
Your parents get money, and if you can't afford your own funeral, we support that as well. So it's basically everything you can imagine doing. And I've been a developer for 15, 16 years. Mostly, I realized, I think, when I've been working for 6 or 7 years, that the funniest thing is to solve problems for other developers instead of. So I've basically I've been taking all my bitterness and as a frustrated backend developer to make application platforms and trying to make it easier for people or developers who make products, to help them instead of trying to figure out what normal people like, because I know what developers like, I don't understand what normal people like.
So in other words, developers as clients.
Yeah.
So I like that idea that you kind of you take the bitterness that you have got. I think many people have that. It's just like, but it should be done like this. Yeah. This would be a much better way, and actually turn it into something constructive. And I think that's kind of almost the kind of the basis of a lot of open source development. It's just like, I've always wanted this, or this should be better. Well, I can do it.
Yeah.
And you do it. And as I understand it, you've been working on a platform. And that's open source itself. So,
I started to work on platforms when I worked at Finn, the former company, which is Norway's, at least for some ways of measuring, it's Norway's biggest website. And I made an application platform there. And then NAV used to be, we used to think of it as the worst place, at least in Norway, to make software. It was all consultants, and they'd made a strategic decision not to hire developers.
Okay.
They only used Accenture and Capgemini and everything, and architects, of course. And then they've got this new CTO, and he said, we need to insource and we need to hire developers. So my friend Truls was the first one, and I was like the 6th or 7th, and now we have 400 developers. Wow. So we kind of built everything from inside a really large governmental organization. We built a new software department.
That's really cool.
Yeah, and the first thing we did was kind of building. The first thing I did was building an application platform and trying to use that as a tool to make people understand that it can actually be. First of all, you can have normal, even good software in the government and in the public sector, and it's kind of cool to work at NAV. So we open sourced it because it's the one thing that no one can argue about open sourcing. Is basically it's Go code talking to Kubernetes and Docker. So it's not any state secrets. So we used that to build our brand, basically. So the platform is called NICE. We found a funny word first, and then we retrofitted it. So it means NAV Infrastructure Service or System. No, NAV Application Infrastructure, and you can choose between service and system because it doesn't really matter.
Because it doesn't matter, because you made up NICE first. It's like, right, what can we do to fit that? That's really interesting as a kind of as a transformation story, because I think what you described is a common experience for many people in many different countries, is the idea that government software is not the place that you want to work. Whereas logically, we should be thinking that that's the place where we want the highest quality.
Yeah.
If you think about it from a social responsibility perspective, surely they should have the best software.
And there's many other things, like there's really no competition. And it's the scope is we have some mainframe stuff, old IBM COBOL stuff, and we have the strangest Oracle thing you probably never heard of. It's what Oracle had before Oracle and IBM invented the application server. So they have. It's actually it's the instances of the Java objects live inside the Oracle database. So it's not like stored procedures.
I
it's
remember that.
Yeah. And to develop this, you have to have your own instance of the Oracle database running on your machine, and nobody wants that. So we have 40-year-old systems that have been important for Norway for that time. And to realize I'm never ever going to write any software that's going to be important for 40 years.
Yeah.
And to understand that's what we're going to replace, it's both scary, but it's also nice.
So that's really interesting. So you've got and I think one of the other things people associate with government software is obviously there's the whole legacy. There are systems that date back decades that we know little about, and yet a lot of people rely on them. But also you're dealing with ridiculous amounts of, particularly in the modern society, and the kind of the amount of data that is associated with any individual in any society. You are dealing with ridiculous amounts of data, but these are all little. There's all these little domains, and you've got all these different systems, which I'm presuming don't necessarily talk to each other comfortably, but I presume we want one view of the data or to have a coherent data flow.
Yeah, very much not very good connectivity for the data. So what we've been trying to do is, first step was basically just to make it sustainable, to be able to make a system that is changeable for more than the project. And that, of course, takes a bit of time, because that means you need to build the teams and you need to build the organization before you start to build the systems. And then after that, we try to build the system around the domains, as you said. So we have something for the sickness benefit and something for the parental benefits and the age pensions and everything. And then trying to figure out good ways of making it possible for these applications and these teams to change in their own pace.
Yeah.
But still being able to communicate in between, so trying to have the loose coupling, as everybody talks about, but still and share just enough, but not too much data is probably the. And
I think that's the kind of, particularly with, I think that's one thing that when people are working within companies that have a single focus, they might not appreciate. And likewise, if anybody who's worked in a startup culture, that it's just like you get to choose your focus. But here, you're actually dealing with lots of things that are pulling you in different directions, and have done for decades. Even before you were there, and long after you will be there. And exactly as you say, there's this kind of interesting kind of compromise. You need a looseness to allow change, but you also need to have something that is together enough. So given you the migration, the journey that you've kind of taken it on, well, okay, you mentioned Kubernetes, you mentioned Docker, you mentioned creating the NICE platform. What does that mean in terms of, I don't know. Or you also mentioned actually that NAV covers traditionally what in other governments would be 15 or 16 departments. That's a lot of, I don't know, is there a term for it? Domain share. Yeah. It's just the one unified view. There isn't one unified. There isn't a single coherent model for everything. No, there used to be, because that was the old way of doing it, and people realized that doesn't really work, because it kind of blocks everything. There's this old saying that, I don't remember the English, when two people live together and they're not married. Samboer in Norwegian, I don't know what that means in English. Anyway, people say there's 14 different definitions of that word in our systems. And the funny thing is, then they think, well, then we need one definition. And then we come in and say, well, we don't, because it means 14 different things. Yeah. So instead we need to understand that it means 14 different things. And whenever two systems talk together and have different understanding of that term, then they need to figure out what it means. But
to try to make this big model of what everything of one specific meaning of every word is almost impossible when they're so as big as we are.
I think that's a kind of there's an interesting collision there between what we desire, as particularly from a developer perspective, like, wouldn't it be nice if everything could be, we can have one definition of this, and what the real world does. And I think even in the real world, we're not very good at acknowledging this, that there are actually, the words have context, specific meaning, and they also drift and change in their own way.
Yeah, because it feels like common sense to have one specific definition.
Yeah.
But if you take that over time and say you're going to keep that model over 10 years and everything is going to change at different paces, it's almost impossible to keep that.
And that I think I first experienced that trying to talk to somebody about kind of a domain model, or actually it was an entity model, specifically what they referred to it in a medical environment in the 1990s, and it's like, what does patient mean? And it turns out that different parts of the medical space have different meanings and different information requirements for the word patient. And that's just what most people think of as one domain, and actually it has multiple subdomains. The minute you move outside that, then suddenly you get all of these difficulties. So I think that kind of takes us into the area of domain-driven design, which I know that's something you're interested in, and it seems to really apply here.
Yeah, definitely. I think I've spoken about. I think it's chapter 14 in the Big Blue Book about the strategic design and how we can have different models connecting and customer, supplier, and everything. And I'm trying to explain that to, for instance, the legal experts. Because another funny thing, because everything we do is kind of grounded in a law, so the benefits have different chapters in the law. And there's the same thing there. It's reuse. Yeah. So the parental benefit and the sickness benefit points to the same chapter. Saying we're going to calculate the amount from this. And then everybody says, well, then this has to be some common service, of course, because it's the same chapter. And then when we try to implement it, we see that, well, it doesn't, but it feels like the law has if statements. So we figure out it's not exactly the same. And the contexts are extremely different, because parental benefits, that's something you enjoy. That's a good thing that happens. And so the sickness benefit, it's something bad that happens to you. So trying to make that into one system doesn't really make sense, even though it shares the same chapter of the law book. So and that's kind of the domain-driven design kind of gone further, because you have to, it's not enough to think about the technical side, but you have to think about the legal side and the communication side and everything.
And I think that's an interesting one, because you mentioned of the Blue Book, it's the strategic design chapter, which it's, Eric always said, that's the bit that people always ignored, and a lot of people never got that far into the book. And yet, I think in recent years, it's an area people normally grab onto the early part of the book, and the patterns in the book that seemed very intuitive from a developer perspective. But this other stuff seemed not immediately obvious, but things like bounded context have become very popular in recent years. And this idea of saying, well, actually, we don't have to have a uniform, although we use the term ubiquitous language, it's not actually uniform and universal. It's the idea of little local subdomains. And as you say, in law, law has a lot of subtleties to it. Speaking as a developer, and I've read a couple of things in law, and no shortage of legal documents, I'm always surprised at how loose they seem compared to code. It's quite interesting. You get used to code, and people say, "Oh, legal documents, they're so boring." It's just like, have you tried reading code? And the legal documents are actually surprisingly imprecise, or they rely on a lot of context that is unspoken.
Yeah, and I think it's also because the code is, at least normally, it's much faster to change.
Yeah.
So, and it's probably a good thing that laws take a bit of time to kind of evolve, and it's easier to change the code. But that's why they think they can't define everything, because then when the world when there's a pandemic or whatever, they have to change everything, and that's that's too slow a process.
So that kind of sets us up with the kind of really interesting thing that you've got a number of different teams. You've got a number of different teams, a number of different software requirements, and dividing them. That kind of leads to very different data flows, different applications, but at the same time, you're still trying to get something coherent. What does the data look at the back end? I mean, it's just like, how are you organising that? Because you're talking, there's COBOL, there's Oracle, there's...
Well, almost all the new stuff we write is Kotlin on JVM, but for communication parts, I would say what we kind of divided our nav up to what we call product areas, which is probably, we have about 10, I think. We might have 15 when we're done, or not done, but when we kind of reached our limit. And then we try to say that between those we should have asynchronous communication. Streams, we use Kafka, but that doesn't really matter. But so you should communicate events, and then you should listen to events, and that kind of makes it easier to achieve the loose coupling and easier to evolve differently. And that makes the teams, at least some of the teams that make our most complicated systems, to become more event-driven as well.
Yeah.
And that's really good. My experience is that when you go from a monolithic approach to microservices, and until you kind of realize that you need to be asynchronous, you won't get all the benefits of dividing up and making microservices.
So I think that's kind of an interesting one, because I think people often overlook the fact that synchronous is coupling in time, whereas people often look at coupling as a very immediate. This box depends on this box, this service depends on this, or this class depends on this. And they think of it as a very immediate thing, whereas actually there's a coupling in time. And asynchrony allows you to just let the parts move at a slightly different rate and execute at a different rate. And
what's happened when you kind of go from events to streams, so we have the Kafka streams where we have the events stored for some time, you can play them back as well. And then you realize you kind of have a superpower, because then you can, when you have immutable data, so you can always understand that what I read is never going to change, and then so when you play everything back, you can change some rules, and then you can play back, and you can get a new reality afterwards, and then that makes it even better to be asynchronous.
So that's kind of interesting, because in other words, that you get to manipulate time, which I think is everybody's kind of fantasy. So maybe I could be a time lord. But there's another interesting thing there, that there's from the traditional perspective, there's a kind of an inversion of dependencies, and I mean that in the deepest sense, as opposed to the way that people often mean it. But the often when people have organised large systems, they have looked at it in terms of, we are organising it around the services, and the services are the first class concept, or they've organised it around the entities, which goes back to our problem with, how do we have a unified entity model? But here we're saying, actually, no, events are the first class citizen, and then we hang everything off that. So as long as we have a truth about events, then actually we can we can actually loosen how we build the applications.
We also seen that. We had a guy called Fred George. He calls himself the grandfather of microservices. And
I will say I first learned about microservices by attending a Fred George talk.
And he has this. Actually, this is a GOTO conference, and it started because me and a colleague wanted to go to Noma, what was the best restaurant in the world in Copenhagen, and of course we were working at a software company, so we tried to find a conference that made it possible for us to go to Copenhagen.
Another inversion of dependencies. We want this restaurant. What conference will allow us to go to that restaurant?
And then we went to GOTO in Copenhagen, and we had Fred George's microservice workshop. Actually, and I didn't realize this till after, because Eric Evans was a participant in that workshop.
Right.
But in that workshop, which I think is the best workshop I've ever done, because you get to code like 6 hours out of an 8-hour workshop on actual problems, not just fill in these tests, but you get to solve problems. He has this pattern which he calls rapids and rivers, which is basically a way of organizing microservices that makes it easy for developers to think asynchronously. So what you do is you have every single service publishes the events to the same topic. And then you filter, that's the rapid. The rapid is the big thing where everything flows. And then the services creates rivers, which is basically filtered views of the rapid. So you get a tiny bit of the event flow into your service, and then you do something, and then you put it back on the rapid. And that's basically the core pattern of almost all the new systems we build now. And it makes it, the one thing, it does several things. It kind of cheats. It makes a shared database that works inside the domain, and also it takes away the question, the doubt developers feel, should I be asynchronous or should I be synchronous? Because it's natural to do it asynchronously, so everything kind of turns into events, and then you get the benefits of it without people thinking, well, this is probably synchronous, and then you stop and then you start doing it differently.
Well, I think that there's a really interesting metaphor again with the whole thing to do with it's rivers. That's basically the write layer.
Yeah.
Everything that happens goes there. The read layer is rapids.
Yeah.
And then the rivers is the read layer for everybody. That's and then ultimately the storage is in the ponds.
Yeah.
Which is it's kind of interesting because that's before. That's kind of like, people were talking about data lakes. So this kind of interesting idea, the persistence is in ponds, which are smaller and local, and you maybe have a pond per microservice, so to speak, and rather than this lake of a single coherent and centrally managed data model.
And it's so easy to keep separation of concern. If you want to add observability, you just add another service that listens to all the events on the rapid and then does it separately. You don't have to add. You can really add logic where it belongs. Although the problem might be that you get too many services and it's difficult to see, but then you just add another service to add observability and then you can see again. But it's
very composable by having these separations and actually saying that if we're allowed to loosen time a little bit, then it allows all of these possibilities. And I think that's quite an interesting kind of observation. And I hadn't come across this one until recently and didn't realise that it actually goes back to when I first saw Fred George. Just after when I first saw him, he talking about programmer anarchy, about the way he organised teams. And that's where I first encountered microservices. That's like 2012. And he had a very strict definition of how he thought about microservices. And he did do it on size. We seem to have given up I think people have just given up on the idea of,
given up on
it's just like, people get it, we ask people, it's like, well, why are they micro? Well, let me show you this micro. That's not micro in my book.
Only reason we can't call them services because then you go back to SOAP and the service, the SOA thing.
Except that I think modern services are now bigger than the stuff that we had under.
So we should probably just call them services and it's
time is cyclic, that says. So I think there's a sort of an interesting observation there, and I hadn't realised that there was this broader view. Now, how does that relate to things? I don't know, because this idea of having different read and write sources, introducing a little bit of asynchronicity to allow the kind of like the parts to move more freely. There's sort of on a parallel branch, CQRS. There's kind of, they seem to have a kind of a shared goal, if you like. They have very different histories, but they appear to have this kind of shared goal. What would you how would you compare them?
I kind of agree. We never really had CQRS as a big thing because it kind of comes almost, well, a few of our teams manage to think more like that because they have the bigger. Some of them have really big microservices, where they kind of model the law part, where they had to model kind of a whole person's sickness history to be able to, and that becomes quite a big object-oriented model. And there they try to have the CQRS, so they have kind of the events and the commands coming in, and that. But others, it's not. It feels, at least from my perspective, it feels less like something that's on the developers' minds than it used to be. Well,
it was interesting because I think that one is more. I found originally that was more intuitive because it was closer to something that I had done, but was not exactly the same. And seeing this rapids, rivers, ponds kind of approach, I thought, that's a really interesting, different way of looking at it.
Yes, well, but the teams doesn't really do that much of it for reasons.
Yeah, they live within it, as it were. In other words, the architecture is around them. So in that sense, it seems more like, I know when we normally talk about architecture, people like to use building metaphors, but this feels much more like urban architecture. It's just like the developers stay in their own houses and they do what they want in their own house, but how the streets and the services are organised, that's really what you're talking about at that level.
And I think it's important to, when you have this Kafka topic, that you keep the idea of what's data on the inside versus what data on the outside. So the rapid is only for us one domain. It's for one team, for one thing. And then if you want to share data with others, you need to make a different topic. And at least before, I've had really bad problems where people thought that every event was available to everybody. So we kind of forgot everything about public and private. And just because it was an event on a service bus, it doesn't mean you can't. You still have to keep your boundaries.
So that's, again, there's this really interesting tension, isn't there? There's this kind of idea of like, we still have to have some separations, but at the same time, we want to get rid of separations, and these two are pulling in opposite directions. So I think software architecture...
And when there's different teams, you have to change slower than when you're just exchanging data with the guy sitting next to you.
It seems like gear matching in in manual-driven cars. You've got to get just right. So I think that's an interesting kind of way of looking at it when we kind of take the big picture. Now, you mentioned a couple of technologies. You also mentioned a couple of programming languages. So you mentioned that the NICE platform is being developed in Go, but you also mentioned I think the application developers are using primarily Kotlin. So you've got a kind of a Go lower level and then a JVM biased up level, but with a bias towards Kotlin. Just out of interest, what informed those decisions?
That's a good question. I think from a platform perspective, Go has the best libraries, I think, at least had in 4 years ago when they started doing this. And then it kind of grew from there. Kubernetes basing is made in Go, Docker is made in Go. So it was easier to start building that in Go. And it also feels, I don't know if you've written much Go, but I find Go to be a frustrating language to write and a good language to read.
It is a little bit, I don't have deep experience. I consider myself a Go tourist. And there is a certain frustration because the language has certain limitations in certain cases. And familiar as I am with lots of language models, it's kind of like, I wouldn't have put that limitation there. But that readability thing does make a difference.
It feels like, at least in the start we thought that maybe the application platform would be slower moving, but it turns out that because the team is very good, they can also manage to move very quick. But then from the application side, we normally say that we have the language we have most code in is Java, but we write most Kotlin. And I never learned the language as quick as I did when I went from Java. The bitterness comes from Java. The bitterness comes from Java.
Okay, now we've completed the story. Where did the bitterness come from? Now I understand. Okay.
And then to go on to Kotlin was quite as easy a transformation I've ever had, I think, going from one programming language to another.
So it's kind of interesting because I know a number of people who are... Their reason for looking at Kotlin is Android, but that's not the reason here.
No, we have no native apps at all. So it's basically, I can't totally figure out who started, but it became a movement, I think. And we really, one of our philosophies when it comes to technology choices in Nav is that everything is allowed as long as you broadcast it to the company. So we have our own internal technology radar to persist all those choices and make it available for all the teams to see. So it started out in some corner and people saw that this actually works, and then some libraries, the library we built around Rapid Servers is Kotlin, so it grew from there. But we still allowed a few people to write Spring and Java as well, just
to keep them on board. So it seems there's an interesting thing here. Let me just pick up on a kind of theme it's just occurred to me. There's in that case this idea of building a developer culture, and also that NICE is open source, and there's a lot of this idea of like, well, as long as you broadcast, as long as you make this information available, and that seems to be a very again, it's another inversion of how sometimes people try and get things done. In other words, it's not a ground. It's not a sort of a command and control. It's very much a ground up kind of approach. And I guess leading by example. Here's the thing I built. Let's that team's using this. You can see the examples there. Which kind of makes I wish more organisations would be aware of that, but it's very interesting to hear it from within a government organisation.
I think we managed to build a really good culture around that because it makes the teams responsible as well. We respect the fact that they know best what tools they can use and what techniques they can use, but also we need to be able to see what you're doing. Before we had a big problem with shadow IT, where people did use stuff, but nobody said anything. And specifically for governmental organization, we we can't use stuff without paying for it.
Yeah.
And when it's in the shadows, no one will say I'm using it, so no one will pay for it. So to be able to get everything out in light, it helps us also to follow the regulations. And as I keep saying to people, software developers should be the first ones to voluntarily pay for software they use, because it's our business. So
yeah.
Right now we don't work for a tools company, but you might sometime later, and then it's good to be able to know I paid for the stuff I used before.
Yeah, no, that's an interesting one. But I also the point you make about shadow IT, I think is very common in a lot of government-related work. And I know somebody who worked. I don't know which bit of the Norwegian government, but it was many years ago. So definitely, it was in the 2000s, and it was interesting hearing what they described as what they're supposed to be doing and what they're actually doing to work around what they're supposed to be doing. In other words, a lot of games rather than something that
I think before we had the tech radar, we had this list of allowed technologies, and I think we had Subversion on there at least 4 years after everybody started using Git. And that kind of shows it's almost impossible to have such a list centrally managed and up to date. So just saying that's not possible, it's better for you to do your own choices and broadcast it, and that actually scales. It's
interesting enough, it goes back to this idea of the cost of centralized locking. Yeah. It's the same in development as it is in the runtime. Yeah. That there is a huge cost to try and keep everything synchronous. So at the scale that you're talking at, asynchronicity both in execution, but also actually in terms of how teams evolve and are organised. Now, one other area which I think is interesting, and I know you've mentioned in the past, is data mesh stuff, because that's a kind of a more recent trend, and it seems to fit with everything that you're saying. The idea that perhaps we don't try and have a single source of truth that is a physical single source of truth, that actually what we should, I guess data mesh is for data as microservices are to monoliths. So
it's very. The first time I read the article on martinfowler.com by Shamak Dagani, I thought, well, this is basically someone that's managed to articulate the domain-driven design thinking, but with analytical data in mind. Yeah. And then I spent almost a year being frustrated because, for reasons which I now understand more of, all the data people couldn't see that. Yeah. For me, it was very clear. Well, this is basically summarized what we've been doing in the application space for 5 to 10 years. And someone's actually explained to you how it works in data. Yeah. And then, but of course, it's a bigger change for them because they're very tool-driven. There's very monolithic. The central data warehouse is like, you can't be more monolithic than that, I think. So to be able to find ways to explain and maneuver our organization into thinking more about splitting the ownership and taking the analytical creativity and the analytical minds into the teams so that they're closer to where the data originates. So they stop being frustrated because the thing they have gets data out of the database doesn't work because the database is changing. Yeah. And I say that before we had like a few really, really big databases that changed 4 times a year, and being the central data warehouse team was difficult already then. But now we have 2,000 databases and they change daily. Yeah. It is almost impossible to follow through. So trying to make everybody think and understand how should we think about getting the analytical data and the data products now when the architecture of the applications are changing. And
I think that's a really interesting way of looking, but it also highlights something else. There's a difference in sometimes cultures. In other words, you talked about sort of the data people, and we had the application people, and they pull in slightly different directions, and there are these different movements within each. So we have it's like the data world is kind of catching up, but also we rely so heavily on data. Modern government relies on data.
And all the things we can get out of these analytical minds and what they think about when they design data models and understand the other uses of data than just fetching something from an API and comparing it and throwing it away, but to understand that the data is actually even more valuable than the codes most of the time.
Yes, indeed. I think that's one of those things that we always recognize that, but that ultimately is the data will outlive all the applications. But I think in the past, that has meant that people have become complacent, and they've assumed that because of that they won't touch the data, or we can't change the schema, we can't do anything new. The data is, it's in a different geological period. The applications move at this speed, and then everything else moves much more slowly, and that this is really kind of like bringing data in at the same speed. Because
there's so much value as well, and trying to figure out. Sometimes we've been able to build the teams where the developer or the application developers and the data engineers and the analytical people have worked in the same team, and to see the value they get from when the team wonder about, should I do this or should I do that, and then he can just do some SQL magic, and then 2 seconds later he knows, well, 45% of it is this and 35% is this, so you should do this, and then to have that ability really close is really valuable.
Yeah. So again, there's a kind of an interesting thing here about time and turnaround time and responsiveness, but also at the same time loosen the coupling, allow. So I presume that looking to the future, that you're anticipating that NAV is going to continue growing, but also from the software perspective, and that they're also all of the products that you're dealing with are also going to be growing.
Well, we still have. Of our four biggest legacy systems, we only really managed to modernize most of one of them. We started on the second one, and then we have slight plans for the third one, and really no plans installed for the fourth one yet. So we still have loads of modernization, but the thing is, well, I'm looking forward to what happens when we're kind of done with the modernization. Yeah. When we get to proper software products that can evolve with its context, and trying to say, for instance, just having analysis and feedback going back to the people making the law, saying we have a really cool thing now where we managed to, in the code that evaluates a case, it connects it to the different paragraphs and the different sentences in the law, and puts it into puts each evaluation of a sentence on a Kafka topic and puts it into another database. So we can do analysis saying, well, these 2 sentences in the law always goes the same way at the same time. So maybe we don't need both. Maybe we can take one away, or this is never evaluated at all. So being able to really get data-driven on how to make laws.
That's really interesting. Observability for the legal system. I had not thought about that, but that's a really...
and then we can do simulations. The politicians can say, well, what happens if we do this? And we can, well, at least some point in the future we can say, well, if you did this 5 years ago, this would have been the consequences, at least for the one part of the system.
Goes back to this idea of replaying time. Just what are the consequences of doing that? Well, that's incredibly powerful, but that's I think a feedback loop that many people probably wouldn't even imagine to have. I think that the point there is that the fact that is now a possibility is itself exciting.
Yeah, and I'm really... So that's what kind of drives us on, that we just need to finish all this, get away from all these mainframes and Oracle systems, and then try to get evolvable software that can...
But I think that's in other words, that idea that information should be you should be able to have the information that you need, rather than, I think a phrase that I've found myself using a lot is that we spend a lot of time programming in the past. In other words, we might be sitting there going like, okay, here is the code I see in my IDE, but actually when I look at the code, it's actually 5 years old, 10 years old, 20 years old. I'm talking to a database that is maybe 30 or 40 years old, or that, in other words, although we think of ourselves as programming in the present, actually a lot of the things are the decisions that are in the past and not necessarily the ones we want today, and we feel powerless to change them.
But at the same time, we always try to think of the code we have now as the code that survived. Yeah. And for a reason. Yeah. So legacy in our terms normally is kind of a bad word, but in normal English at least, legacy is a good thing.
Yes.
So we always try to focus on the fact that this system has been important for 40 years. That's a good thing. We need to change it now, but that doesn't mean it's been bad for 40 years. It's been really good, and it's built the world's best welfare state. So to be able to treat them with respect at the same time as saying, well, now we need to change them because now we have other options.
I think that's a really interesting way of looking, because the legacy is a funny word, the way it's got used. I discovered a Twitter comment, and then I sort of started digging around. I quite like language, and so I actually dug into the Oxford English Dictionary, and the earliest citation for using legacy in reference to software was 1989, which actually feels more recent. But
language terms,
in language terms, it feels very recent. And but what I found absolutely fascinating is that it got taken up very, very quickly because it clearly fulfilled a need.
Yes.
But then we've also got this other use of the word. In other words, that legacy we'd like to think of as positive, but it isn't always. But I think one of the more interesting things is, and it relates to what you're saying, is that I always tell people there is a genuine positive about legacy code is that legacy code has a history, which means you can tell something about it, which you can't tell about new code.
No.
The code this is new code. We don't yet know how good it is, or how relevant it is.
Solve the right problem?
Does it solve the right problem, or have we solved the problem in our heads, not the one in the world? Which I think a lot of developers might be guilty of, and I know I have been. But that idea of this idea it has a history that we can actually go and look at and go, actually this is useful, or actually it hasn't been useful for a while, and we just hadn't noticed. Whereas new code is experimental and should be experimental. We should be allowed to throw it away.
because that's our superpower. Yeah, we can change software on our whim. I remember reading an interview with one of the guys who worked at Nav from the very beginning. He was retiring a few years back, so we've been basically working 40 years on the same system. And he kind of divided everything into decades.
Yeah.
Well, the first decade was quite good, and then the second decade came, and then some politicians did bad, there were some consultants. But the third decade was better again, and just to have that time span of understanding how the system you work on affects the real world and the other way around sounds.
Yeah, I think that is sometimes when people properly appreciate software architecture and development organizations, they start talking, it's a socio-technical system, and you start to see it with these kind of long views. But I think that idea, as you say, the idea that in software development we have a superpower. Sometimes we don't use it. That software should be soft. We should be able to change it, and we should be able to do so as quickly as possible, but we should also be able to understand it in a bigger historical context. And that would be, it's a superpower and a right in that sense, if we get it right. Okay, so I'm going to bring this discussion to a close. We've kind of covered a remarkable amount of space. What are the kind of things that you think are interesting from a personal perspective, but also in the context of NAV and NICE over the next few years? What are you've already mentioned a couple of things you're kind of looking forward to, but...
Well, one thing we're working on right now is continuing our migration to the cloud and trying to do that in a way that actually makes everything better and cheaper and everything. And another really interesting thing that me and a colleague has been working on lately is to try to balance the creative autonomy of teams with kind of the large-scale efficiency of alignment. To try to figure out a way to control the teams without actually making them feel like they're being controlled. But
control without control.
And we've been working quite a lot. Technology radar is one example of one technique you can use to do that. And then we have some other techniques where we try to balance the normative and the descriptive parts. So we spend some time saying this is good ways of doing stuff, and at the same time saying, but you can choose yourself. Everything is allowed, but you just have to broadcast it. And trying to find that balance so that a system of teams that are more than 100 can both be similar, but also try to figure out what's the best way of moving forward, because we don't want to create a new system that's impossible to change because it's 40 years old. It has to keep being changeable.
Yeah, you don't want to create somebody else's bad story.
No.
Oh, that's brilliant. Thank you very much.
Thank you.
Thanks for listening to this episode of the GOTO podcast. Head over to gotopia.tech to discover lots more content from the brightest minds in software development.